Well, hello. So, whole observability theme together for us, we have Dotan to take us through the OpenTelemetry project and how to get started with it. So, all these themes, traces, logs, metrics, the three pillars of observability. And of course, we all fell in love with microservices until we had to think about resolving problems with them at scale. So, just how do you pull all of that together? And a note from the online chat this morning also that Dotan's promising us hot updates from last week's QCon. So I can't wait to hear that. So over to you, Dotan. Please take it away.
Thank you very much, and glad to be here. And I was last week at KubeCon, so lots of fresh updates to share with you. I'm really excited. Got a lot of feedback on my talk there, so hope to compile all that into our session today. And the session is about OpenTelemetry, and I would like to start with a very basic question. Essentially, how many tools would you say the average company uses to collect telemetry from its systems? And when I say telemetry, I mean logs, metrics, traces, obviously across your front-end app, your back-end app, infrastructure, AWS, Azure, Google Cloud, open source frameworks like Kafka and Redis and whatever. So across all of these together. And the amazing thing is that a recent survey that we've done shows that organizations use between 5 to 10 different tools to collect telemetry from the systems. 5 to 10. You can reduce it to one standard unified platform. Here's the story of OpenTelemetry. A word about myself. I'm the principal developer advocate at logs.io. At logs.io, we provide a cloud-native observability platform that's based on popular open source tools such as Elasticsearch, OpenSearch, Prometheus, Jaeger, and obviously also OpenTelemetry. I personally am an advocate of open source and communities in general, and the CNCF, the Cloud Native Computing Foundation in particular. That's the foundation under which OpenTelemetry is, as well as Kubernetes and many others. I co-organized the local CNCF chapter in Tel Aviv. So if you're around, do join our meetup, our meetups there. I also have a podcast called Open Observability Talks that discusses DevOps, open source, and observability. So do check it out on your favorite app. And in general, you can find me everywhere at Horovits. And now let's talk about observability. As we all know, the observability is essentially the ability to understand the state of our system based on the telemetry data it emits. And the vision talks about unified observability across different signals, primarily logs, metrics, and traces, but also across different sources. So think about your front-end code, your back-end code, open source tools, cloud services, essentially fusing all of these together to gain unified observability. That's the vision. The reality, however, is much more fragmented. And the reason is exactly what we talked about before, that we use so many tools for our observability. And each tool and each vendor has proprietary APIs and SDKs for instrumenting. Think about your Datadog agents and Splunks and New Relics and Jaegers and others. Then also proprietary agents, daemons, collectors for collecting, running all sorts of aggregations and sampling and other processing. And then proprietary protocol and data model for transmitting that telemetry data to the analytics backend. And all of that is, first of all, obviously an operational headache running so many different tools. But more importantly, if we go back to observability, it creates tight coupling between the collection side, the telemetry collection, and the telemetry storage and analysis backend. And most importantly, it makes it very difficult to correlate data between and gain that unified observability across these essentially data silos. And that's what OpenTelemetry comes to solve, the open source project. OpenTelemetry, or OTel as it's nicknamed, is this is the formal definition, an observability framework for generating and capturing telemetry data from cloud native software across traces, metrics, and logs. So essentially you get one framework to rule them all, if you'd like. And it's also open source. It's an incubating project under the CNCF. And in fact, it's the result of a merge between Open Tracing and Open Census project. So if you are familiar with these CNCF projects, or maybe even using them, if you're using them, by the way, that's time to move to OpenTelemetry, but we'll talk about that later in this talk. This is the roots of OpenTelemetry. And I think one of the most exciting things that I would like to share with you, if you're not familiar, is that OpenTelemetry is really widely adopted. I think all the major players in the industry have aligned with OpenTelemetry. So look at AWS and Azure and Google Cloud, look at Datadog and New Relic, and everyone is aligning with OpenTelemetry, which is great news. And secondly, and maybe even more importantly, it is the second most active CNCF project today, second only to Kubernetes itself. So that means that it's really active. And by the way, this is taken from the CNCF DevStats dashboard. You can access it publicly and check it out. And the reason I'm excited about it is that we would like OpenTelemetry to become a de facto standard in the industry. And I think these are the key elements that you need in order to create a de facto standard and converge the industry. So really, really positive signs behind the adoption and activity around OpenTelemetry. And I hope that I got you intrigued enough to want to hear some more. So let's talk about more about what OpenTelemetry provides us. So in essence, OpenTelemetry provides a unified set of vendor-agnostic APIs, SDKs, and tools for generating telemetry data, logs, metrics, traces from our applications. That's the bluish part on the left-hand side. And then a standard way for collecting the telemetry data. That's the green part. And then a standard way for transmitting and exporting that data. That's the orange part. And exporting to whichever backend analytic tools you choose. So you want to send it off to Prometheus for analysis, to Jaeger, to Logs.io or any other. It's really up to you. OpenTelemetry does not take any stand in the backend. It's just the generation and collection of the telemetry itself. And that's OpenTelemetry in a nutshell. And now, don't worry, I'm going to dive deeper into each and every one of these components of the project. But before I do that, I'd like to say a word about something that's not exactly a component, but rather it governs all the components, and that's the OpenTelemetry specification. And the specification describes the cross-language requirements and expectations for all of OpenTelemetry's components. It includes the API specification, the SDK spec, and the data spec, things such as semantic conventions and annotations and so on for traces, metrics, and logs. And although the common user usually doesn't interact directly with the specification, it's very important to understand it, because this comes to solve the problem we talked about before, that that fragmentation, that each vendor and each tool has its own API and its own SDK and each signal also for logs different and metrics and different and traces and so on. So this is the element that allows us to converge also across programming languages, having one unified specification. So that's about the specification. And now the first component that probably most of you will encounter is the OpenTelemetry client libraries. OpenTelemetry offers one API and one SDK per language, based on obviously the specification we talked about, for instrumenting your application. So you have one for .NET, one for Java, one for Go, Python, and so on. You can see here the logos. And that's for the manual instrumentation, for actually changing your code to make sure that it emits logs or metrics or traces. On top of that, you also have language-specific integrations with popular web frameworks, storage clients, RPC libraries, and so on, to automatically extract things from these libraries. And also, there are also in some libraries auto-instrumentation agents that allow you to collect telemetry from these languages with zero code or near zero code instrumentation. So essentially, you have the full range in OpenTelemetry from, at least this is the mission statement, providing the full range from fully manual instrumentation to fully automatic instrumentation and anything in between. And depending on your situation, you would choose the right tool for the job. For example, if there is a third-party framework or some other piece of code that you're not allowed or can't change or modify, then you need to use auto-instrumentation. However, if it is your code, then you can decide. You can start with auto-instrumentation and then add custom manual instrumentation for very specific parts of your code that you want to zoom in and get finer granularity, for instance. So it's really gives you the full range. So that's the client libraries. The next component that I'd like to talk about is the OpenTelemetry collector. And the collector can collect data from OpenTelemetry's SDKs that we talked about before, the Java, .NET, and so on that OTel provides, but also from other sources like Kafka, MySQL, Redis, cloud services, and so on, and then export this telemetry to supported backends. And it's built, as you can see here also on the screen, like a typical data processing pipeline. So you have receivers in multiple protocols, then processing and aggregation, and then exporters in multiple protocols. So, for example, it can collect telemetry from our application. For example, if my source code emits traces in a Jaeger format, I'll just use a Jaeger receiver. If I use Kafka, I can use a Kafka receiver to collect from Kafka. If I use, I don't know, HTTPD, I'll use HTTPD receiver and so on. I'll just plug in the relevant receiver, collect the receiver, and so on. Then I have different processes to do different things, such as filter, modify, batch, sample, and so on, different operations. You can also chain different processes together to get more elaborate logic. And then at the egress, you can use the relevant exporter based on the backend that you choose, the analysis tool. So if you want to analyze it with I don't know, AWS X-Ray, you'll use AWS X-Ray Exporter. You want to use Azure Monitor, you'll plug in Azure Monitor Exporter. You want to use Prometheus Remote Write Exporter. You want to use Logs.io Exporter, and so on. So really up to you. That's the collector. And the last component that I'd like to talk about is the OpenTelemetry Protocol, or OTLP, which is a general purpose telemetry data processing delivery protocol. It could be used, as you can see here on the screen, to transmit between the SDK and the collector. It can be used to transmit between the collector and your analytics backend, as long as the backend supports OTLP. It can be used between two different intermediary nodes, like two different collectors, or any other purpose. It's really a general purpose, a client-server request response type of protocol. It's implemented over gRPC and HTTP 1.1. So you have OTLP over HTTP and OTLP over gRPC supported. It currently supports binary protobuf encoding for the payload. And there is plan later to also add JSON for the payload. So you'll have JSON encoding for OTLP over HTTP. And obviously, based on the specification we talked about before, there's also the telemetry data model that defines the exact way of representing that payload. And a very important note that I would like to make here is that OTLP or let's put it differently, OpenTelemetry does not force you or mandate you to use OTLP protocol, although that is the protocol of the project. You have the freedom, as you saw before. For example, the collector you saw supporting many other collectors, both for the receivers and the exporters. And similarly, the SDK can export in other protocols, not just OTLP. So you really have the freedom. However, I would say OpenTelemetry as a project strives to provide a unified protocol that is part of a holistic framework, and also to enable correlation, because when you send over the same protocol, the logs, the metrics, and the traces, you can create the unification with the data model, with the labeling, semantic conventions, and so on, that enable the correlation as well. And the same concept also goes for other parts of OpenTelemetry. You can work with a collector without using the SDK of the OpenTelemetry. You can use the SDK without the collector, and so on. So it's really, as an architecture, it's loosely coupled, yet a holistic framework, aiming to provide a standard, unified way for generating and collecting telemetry data. That's really the essence. So these are the main components: the client libraries, the collector, and the OTLP protocol. There are other components that I'm not going to get into now, maybe if we have time in the Q&A, but in this scope, I would like to focus on these. And the next up, the question that usually comes up is, okay, but what's the state of OpenTelemetry? And most importantly, is that GA, generally available? Can I use it in production? That's the question that I'm usually asked. And the answer being, it's a bit difficult on the virtual format. When I stood there with, 700 people in KubeCon, there were lots of shouts of answers there. I'll give you the answer, don't worry. The answer is, like any complex system and interesting question, that it depends. And the reason that it depends is that OpenTelemetry is not one monolithic project. In fact, it's an aggregate of multiple groups, each working on a different piece and different component of this massive endeavor. So you have the group working on the metric specification, and another on the tracing specification, another on the logging specification. You have the group working on the C++ SDK and the Java SDK, another one, and so on and so forth. So you get the picture, and each group has its own release cadence, which means that different components of OpenTelemetry may be in different stages of the maturity life cycle. And the maturity life cycle, and CNCF, if you're not familiar with the terms, just to align the terms, it's draft to experimental to stable to deprecated. And just to align it with common terms, stable would be the equivalent of GA, generally available. That's what you'd be seeking to run it in production environment. And it's covered with long-term support, backward compatibility, and so on. And experimental is the beta phase, where you can start POC in that phase. So, okay, that's to understand the ecosystem, but still, what's the status of OpenTelemetry? And here I'd like to break it down by the signal types. And the most advanced signal in OpenTelemetry is actually the traces. And the traces are GA, generally available, stable in CNCF terms. They've been so already for quite some time, which means that the API is stable, the SDK, the protocol are stable, the data model. There are lots of client libraries that are version 1.0 or above, where 1.0 means that the tracing implementation is complete. So you have for Java, Go, .NET, Python, C++, JavaScript, Ruby, Erlang, and Swift, and working on PHP and Rust. And by the way, it keeps on advancing in amazing pace. So I won't be surprised if things updated since the last time I updated the slide. It's really moving very fast and very active groups around each and every one of these programming languages. And one thing that is important to say, I mentioned that before, but just to focus, generally available stable means that it comes with the guarantees for long-term support, backwards compatibility, dependency isolation, things that you definitely be looking for to run it in production. So that's on the tracer side. Next up is metrics, and here I'm really glad to bring you hot news. I promised you hot news from KubeCon from last week. So hot news, we just announced the release candidates for metrics, OpenTelemetry metrics, which means that it's really GA is around the corner. Essentially, the implementation is complete, and now pending user feedback. If nothing major happens in these coming days or a week, it will be formally announced as GA. So you can treat it as GA for anything in purpose. So as I mentioned, the API, the SDK, the protocol, data model, everything is stable. There are already client libraries in Java, .NET, and Python that are in the release candidate phase in version 1.0. JavaScript is expected in a matter of days, and more languages will reach that phase in the coming month or two. So this is the state, and very important to say, we all know that Prometheus is a prominent tool for metrics. So how do they work together? It's very important to emphasize that there is Prometheus support in OpenTelemetry metrics. It has been conducted in collaboration with the Prometheus community that is also under the CNCF. So a very successful collaboration that allowed for OpenTelemetry SDK to have Prometheus exporters and the OpenTelemetry collector to have both receivers and exporters for Prometheus. There's the Prometheus to OTLP data model specification alignment. So a lot of work has been done here, great work. And that's about the OTel metrics. And the last signal is logging, which is the least advanced. It's expected to reach GA later this year by end of 2022, but currently it's still experimental largely. Some pieces are already stable, like the protocol is already stable, the data model. Actually, it's been announced also just a week or so ago that the data model is stable, and the OTLP logs protocol turns stable, aligning with the data model. In general, it's important to understand logging. Obviously, the logs are the most established and long-standing signal. Everything has logs, and even legacy systems, everything has logs. So, and we can't ignore the existing logs and just reinvent the wheel. So the first focus is to integrate with existing logging sources and logging systems, and later on to add the unified framework also for logs. So that's the initial focus, which means that we have also work on log appenders in many languages that allow, for example, to add tracing data on top of logs, like the trace ID and span ID and so on, and to be appended on top of existing logs to allow correlation between logs and traces. And the SDK is already able to send out logs over OTLP, which is a good thing. The collector is still experimental. There was actually a very good push in the collector with a contribution of a project that's called Stanza that brought about lots of log processing in many data formats. So that's an important contribution. And as I said, the SDK is experimental, focusing on allowing clients to ingest data from existing logging systems and outputting over OTLP protocol, along with tracing and metrics. And the API, because that's, as I said, the API, defining a new API would mean that we want to align with OpenTelemetry new specification. So API is still in draft mode. One thing that is important in starting to create the OpenTelemetry standardized logging is work around the specification and to create a strongly typed native OpenTelemetry logging. So there's work on the semantic conventions and there's this work with the Elasticsearch community to align with the ECS, Elastic Common Schema, to merge these two initiatives to standardize logging structure. So that's a very exciting path forward for standardizing logs. And down the road, it will be more work to create this sort of strongly typed and machine readable type of logs, not the free text unstructured format that is currently very dominant. So that's about the three signals, and the state of each one of these. And I would like to take a moment there to really give a hands up and a thumbs up to all the major efforts that have been done by the OpenTelemetry community to really reach this milestone last week of releasing metrics in release candidates and GA very soon. So that's a major milestone, and also the milestone to reach on the log side to stabilize the OTLP logs protocol and the data model for that. These are great achievements just from the last couple of weeks or months. And there are more pieces that I won't get into now unless we have time on the Q&A. But for example, there's OpenTelemetry operator that allows to install on Kubernetes. There's client instrumentation working group working on pulling telemetry from client side, like mobile apps and web apps and so on, and lots of work also to enhance auto instrumentation, remote configuration. These are all from the maintainers discussion, OpenTelemetry maintainers discussion last week at KubeCon to enhance and enable remote configuration of OpenTelemetry collector and the SDKs, even adding more signals beyond logs, metrics, and traces like continuous profiling. So lots of exciting things came out of KubeCon and from the discussions. So follow the discussion in the community. And the last part that I would like to dedicate time on is about how to actually start with OpenTelemetry. And you know, we saw that there are lots of components and lots of working groups and special interest groups, SIGs and tags, technical advisory groups, and so on. So, okay, but how do I get started with OpenTelemetry? And I would like to give you my bit of advice. And it all starts with knowing your stack. You need to know your own stack and what you're trying now to get your own system. So answer these basic questions. First question, which programming languages are you using? Especially if you're a polyglot organization, so you have your front-end app and your back-end app, which programming languages, and also potentially also which frameworks you use. For example, you use Node.js for the front-end with Happy or Express, and you use your backend with Java and Spring framework, or so know these, because this will determine the SDKs and the agents that you will use to instrument your application to extract telemetry. Second, you need to figure out which signals you intend to collect, logs, metrics, traces, and also, very importantly, in which protocols you're ingesting these, which is especially important if you run a brownfield type of project. You already have components somewhere in your system that already emit logs in specific formats or traces in specific format, and you need to conform to that existing component and format, because this will determining the signals and protocols will determine which receivers you'll be using in the OpenTelemetry collector. And lastly, you need to understand which analytics tools you're going to use for the backend to send the telemetry off to for analysis, because that will determine the exporters that you will use from the OpenTelemetry collector. And by the way, it doesn't have to be a single tool for everything. You can decide that you use, I don't know, Prometheus for metrics and Jaeger for traces. Obviously, if you have one framework, for example, my company Logs.io offers a unified framework across logs, metrics, and traces, then you can send it to one endpoint. But it's really up to you and up to your setup and configuration. So these are the questions. And once you figure out your stack, as we mentioned, then take that stack and map it to the relevant components that we talked about, the SDKs, the agents, the receivers, exporters, and so on, and then just check the status of each and follow the guides. And for that, there is a very useful page, OpenTelemetry.io/status, that gives a high-level a status overview of the project and the different components. That's a very, very useful starting point to check out. And there are lots of other useful resources on the OpenTelemetry.io site. You have the docs that are very, very useful for different programming languages and so on. You have the registry. That's a searchable way of finding the relevant GitHub repo for your specific needs. So you need .NET, you type in .NET and in the registry, and it will give you the link, direct link to the GitHub repo for that, or maybe there are several, so you can see which ones are relevant. So the GitHub is massive, and you have the link here also for the GitHub, but so the registry helps navigating very easily. And there's also, actually, I need to add it to the slide, there's also a blog. The blog used to be, by the way, on Medium. So if you see OpenTelemetry on medium.com, we essentially deprecated it, and now the official blog is OpenTelemetry.io/blog. So you'll find going forward the blogs there. So very useful blogs also there. So these are the resources. And one other resource that I wrote, actually, I'd like to invite each and every one of you to actually check it out. It's a beginner's guide to OpenTelemetry that I wrote. You have a short link here that you can now take a screenshot of, or you can just type it in, or just Google OpenTelemetry guide or OpenTelemetry tutorial. You'll probably find it on the top of the list. And this is a guide that provides, first of all the information about the different components that I was talking about, collector, SDKs, APIs, receivers, exporters, everything there. Also detailed status of the different components. And also you have sub-guides to the different programming languages. So if you want to instrument, your hello world with Java, you can find some useful guide there, .NET, Node.js. I'm actually now in the process of releasing one for Nest.js. So if you're from the TypeScript people, follow me at Horovits on Twitter or on LinkedIn or wherever. And definitely, if not today, then tomorrow I will publish the Nest.js tutorial. So you have per language tutorials that you can reach through the main guide. And also, of course, the useful links to drill down to the OpenTelemetry details, just so you have a way to navigate in OpenTelemetry's site. So you're more than welcome to check it out. And with that, I'd like to say a few final notes. I would like to leave some room for questions, obviously. But first of all, if you have any feedback on that guide, OpenTelemetry guide, or on this talk, or anything related, feel free to reach out to me at Horovits, Horovits. I'd be more than happy to get feedback and engage in conversation. But also, very, very importantly, I would like to remind everyone, this is an open source project. So I call each and every one of you to actually get in and just get involved in the capacity that you feel. It could be commenting on issues. It could be opening new issues. It could be getting on calls. There are calls for the different tags, the technical advisor groups. There are calls for the working groups focusing on different areas. So you can get involved on the GitHub, on Slack, CNCF Slack. If you're not there, it's free for everyone. You don't have to be an official CNCF member vendor. And you have Slack channels for OpenTelemetry and the different subgroups. Just go ahead, try out OpenTelemetry, get involved, because in fact that is the way that we can ensure that this in fact becomes a de facto standard that serves all of our needs and to really deserve to become a de facto standard. So with that, I think that I will leave some time for questions. Hey, Finbar.
Oh, that was great. Thank you
Thank
very
you.
much, Dotan. That was an excellent session. I've just
Thank you.
the reason I'm distracted is I've just got my other browser window open for the guide. That is a phenomenal piece of work.
Thank
So
you.
I'm going to get buried in that as soon as I can. That is fantastic to see. Session, brilliant to hear, the release candidate. Absolutely. So we do have the 3 pillars of observability now available to us through the
Yeah.
OpenTelemetry project.
Yeah. Really
I don't know if
exciting.
you can, yeah, I don't know if you can see the question there, but I think it's Amandas is asking around, what if you're Windows native? Does this toolkit still apply?
Yeah, definitely. It's very important to say it's the idea is to instrument and collect data from cloud native frameworks. Although even you can see that even used in monolith. Let's be a bit generalist, but Windows is definitely one of the signals. Some of the signals are the open. Sorry, the operating system, the OS level metrics or logs, or so definitely you can collect from Linux, different flavors of Linux, and you can collect signals from Windows, Windows
Sure.
logs, and so on. But also, if you have containers running, Windows containers like Azure containers and things like that. So it's really meant to serve the general purpose of cloud native architectures, whether
Sure.
Linux or Windows based.
Understood. And then the next point raised by Martin. So, obviously, the whole point and I think benefit of the OpenTelemetry project is how do we manage observability? But for people who might not be familiar with that specific theme, what would you suggest as great resources to the general theme of observability? Where would be good places to start looking?
So that's a great question. Obviously, whoever wants to get into OpenTelemetry, it's a good start to making sure that you understand the basics of observability in general. I touched upon it really in a nutshell at the beginning on the first slides, talking about the need to be able to understand the state of a system based on the telemetry data that it emits. But it's much more than that. So first of all, I'm more than happy to invite all of you to check out my own podcast. I have a podcast dedicated to observability. It's even called Open Observability Talks. Open Observability is one word. So although it's me talking, I think it's an excellent podcast. I have each episode a guest from a different from the industry and from the community, like the creator of Jaeger open source project, or a member of the technical advisory group in the CNCF, the Cloud Native Computing Foundation, a senior SRE from Google. So people giving different perspective, both from the open source side, the tooling side, and the end user side. I think this is and each episode focuses on a different area. So I think this could give a very good, broad, and also in-depth perspective on different areas of observability, and also the linkage between observability and site reliability engineering, SRE, and the DevOps practices. Where is the overlap? Who is in charge of whom? Even the organizational challenges of who owns observability in organizations, when it's not a 10-man strong startup, but rather a large organization. There's a question of how to structure it within the organization. So lots of different questions around these that I think are very interesting in discussing. I also, by the way, had a talk at Open Source Summit last year, 2021, about observability and open source. So, and I give there a more comprehensive overview of what observability is, even before open source. So I may be able to share that link here. And this is also a good resource for starting on observability. Charity Majors is also a very known figure in the industry, talking about observability, and has lots of resources, talks, and written about that, and other thought leaders in the industry. So these are like off the top of my head. I'll try and think maybe afterwards on the chat for some more resources.
Oh, great pointers. Thank you. So I think that's plenty for Martin to be going on. I've got a question. It's probably a ridiculous one to ask, but I'm kind of looking for your impressions really, or or your gut feel at least. If you've got a very, a classically old legacy enterprise application, to introduce something like the OpenTelemetry framework within it, are you you did touch on some of this, but are we looking at a rewrite? Is there a refactoring way through this? Are there even things we can do, which means it's fairly non-invasive to get going? How would we go about, maybe I've got a great big ball of mud and I want to start using OpenTelemetry on it. What's the impact of that kind of effort?
So it's an excellent question, and although I stated the mission statement being cloud native systems, I do think that it brings value also for systems that are not cloud first and cloud native first. And for that, I think I mentioned the component of OpenTelemetry collector, and the collector
Mm-hmm.
has many receivers, a library, an ecosystem of receivers in many protocols. Some of those protocols are more traditional protocols, so that you can actually, without touching the source code of your application, you can still ingest it into the OpenTelemetry protocol, whereby
Yeah,
you can then create all sorts of processing to first transform it to more modern protocols, preferably OTLP, the OpenTelemetry protocol, and also
sure.
start doing all sorts of enrichment of the data and aggregations, and even start the correlation work between that, let's say, legacy signal and other signals in the system. So it can create a good way to start off with OpenTelemetry without having to re-instrument the source code of the application.
Sure.
So I would go about this path, obviously with a gradual migration, especially for new components. What I've been seeing, at least with my customers and members of the community, that new components are being then structured as services, as independent modern
Mm-hmm.
services. So you have the
Yes.
legacy that they
Yeah.
don't want to touch, a
Yeah.
big ball of mud, as you said. But
Sure.
then new developments are being done in a more microservice modern
Yeah.
architecture. And the ability to have OpenTelemetry collector as a unified collector collecting from all of these together can create this alignment across both the legacy part and the newer pieces that are being generated.
Sure. No, brilliant. Thank you. And that was an absolutely fabulous summary. Thank you very much.
Thank
And
you.
certainly for me, with all topics, and there's a lot that's new in this. It's always interesting to understand how to get started. The guide that you've provided alongside this is phenomenal. So I would urge everybody to hop straight onto that and pick up the contact from there.
Yeah.
But
I'll paste it as soon as we finish the talk. I just don't want to not be with you, but as soon as it will, I will also paste the link here. So feel free
brilliant.
to check it out. Uh,
That's great. So thank you very much. We're in at the last couple of minutes, but I think we'll halt it there. We've got a break for an hour, so we'll be back after lunch at 20 minutes to the hour. But in the meantime, Dotan, thank you very much for an excellent session. Thank you. Bye.
Thank you very much, Finbar. Thank you, everyone, for listening.